Assalamualaikum and a very good day to Dr. Suzila and everyone who is watching this video. My name is Alia Akila and today our group would like to present a video on the topic of cooling tower. We are actually from group 1 which consists of 5 team members such that Ahmad Firdaus, Ahmad Tajuddin, Arif Hanafi, Izzat Izni Maizurah and myself. Before we begin to the technicality and detailed point, what is a cooling tower? Well, a cooling tower is a specialized heat exchanger where air is brought into direct contact with water in order to reduce the water temperature. Simply put, cooling tower is used to dump some or all of the acquired heat from recirculating cooling water to environment through the evaporative cooling method. Generally, in industries, cooling tower can be divided into two types which are cross-flow cooling tower and counterflow cooling tower. The main difference between these two lies on the direction flow of the air and water itself. In cross-flow, water flows into the field vertically while the air flows through the flow of the falling water horizontally, while in counterflow, air flows vertically upwards, countering the falling water in the field. Take a look on these diagrams for easier understanding. As for in our pilot plant, a salted water cooling tower was used where water heater was equipped along with a loaded cooling tower process. Hence, input power for water and heater can be controlled by two switches where it used to reheat the return cooled water by the fan in the process. In addition, pump was also switched on to pump heated water to the top of column. Let's take a look at how the mechanism of a cooling tower works.
I will explain the theory on the cooling tower process. Cooling tower follow the first law of thermodynamics, which explains that energy can transform from one form to another, but it cannot be destroyed or created. The energy enters the cooling tower in the form of hot water and cooled from temperature T1 to temperature T2. The ambient air at T1 was blown over the hot water and exits the cooling tower at some temperature at T2. The energy balance is enthalpy, which is H equal to U plus PV. H is enthalpy, U is internal energy, P is pressure, and V is volume. Equation of a method on how to conduct an energy balance delta H in equal to delta H out, whereby delta H equal to delta H in minus delta H out. Uh, there are methods to determine the change in enthalpy. Okay. Enthalpy change can be obtained from the equation delta H equal to delta T. Delta H is change in enthalpy while delta T is change in temperature. Water that enters the cooling tower will lose energy while air that enters the cooling tower will gain energy. The change of enthalpy equation are delta H water equal to delta H water out minus delta H water in, and delta H air equal to delta H air out minus delta H air in. As stated by the first law of thermodynamics, energy inside the cooling tower should be preserved, and thus delta H water equal to delta H air, and delta H air plus delta H water equal to 0. It becomes 0 because delta H water lose energy, thus it become negative, and delta H air gain energy, thus it become positive. And since it equal in energy, the plus of them becomes 0. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Uh, Now I will continue the presentation on the daily application of cooling tower. Okay, from my research, I found that one of the daily application of cooling tower is evaporative cooling tower. Okay, this is the picture of the evaporative cooling tower. Credit to Merck Carpenter Photography. Okay, the application of this evaporative cooling tower in hot dry climates. Evaporative cooling tower will cool outdoor air and circulate it to a space or building. The evaporating water at the top of the tower creates a downdraft of cooler air that can be circulated to a specific area, to a specific space or area. The amount of cool air from the tower is dependent on outdoor humidity, the height of the tower, and the amount of water being evaporated. The example of configuration for the evaporative cooling tower is a minimum of twice the height of the space to be cooled. So, in conclusion, the higher the tower, the greater the amount of air delivered. make the area of the outlet opening, delivering the cool air as large as the cross-section of the cooling tower. Continue to the next part, which is the apparatus used for this lab. There are three apparatus used in this lab, which is the first one was Soltec water cooling tower model HE152, the control panel itself, and then stopwash. Then this is the methodology used for this experiment. The general startup have 10 steps that you need to follow strictly to achieve good results. For the first experiment, the investigation of effect of cooling load on wet bulb approach, there is 8 steps you need to follow, which is the first one you need to prepare as the general startup. And then the second experiment, which is the investigation of the effect of air velocity on wet bulb approach and pressure drop through packing. There are 6 steps that you need to follow as well. The first step, same as before, which is you need to prepare the laboratory as in general startup. So the last one is the general shutdown procedure. There are 5 steps that you need to follow to shut down the equipment.
Assalamualaikum to Dr. Suzila. My name is Ahmad Tajudin Tasnim bin Masaho. Today I'm going to present about the application and feasibility of cooling tower in industry. So the first one is in oil refinery plant. In oil refinery plant, they usually need cooling tower to cool off their reactor, their processes. So in a cooling tower of oil refinery plant, they usually use a closed loop cooling water system. Okay, so what is a closed loop cooling water system? A closed loop cooling water system is a closed system where water circulates and undergoes alternating cooling and heating without interacting with the air. So to conclude that in oil refinery plant, they use a cooling tower that use a closed loop cooling water system. Okay, for the next application, which is in thermal power plant, there are many kind of cooling tower out there. So usually in an energy industrial such as thermal power plant, they usually use a forced draft cooling tower. Okay, so what is a forced draft cooling tower? So I'm going to explain what this is. A forced draft cooling tower is a cooling tower that eliminates low potential heat produced during the production processes. The forced draft cooling tower usually use a wet technology atmospheric cooling and forced draft. The contour flow of air and hot water in the cooling field result in heat transfer that help to cool the industrial reactor. Okay, so that for the second application, and the next application is in the pulp and paper industry. As we all know that heat plays an important role in processes such as pulp and paper industry. So in this industrial, an engineer designed that they think they need to use a plastic cooling tower instead of metal one because the metal one is cost inefficient and expensive. So why did they consider to use plastic? Because plastic offer many benefits which include non-corroding, longer life in harsh mill environment, improved cooling capacity. Instead, plastic is also lightweight compared to metal. Besides that, plastic also do not need coatings and resistant to atmospheric weather condition, and lastly, plastic also leak proof. So as a conclusion, cooling tower have many application in industrial which can benefit humankind.
Assalamualaikum. Today I would like to present on conclusion of cooling tower. A cooling tower
is a system for heat removal that uses water to transfer excess heat from the process into atmosphere. In practice, the cooling tower efficiency will be in between 70 to 75%. The cooling tower purpose is to cool relatively warm water by contacting unsaturated air. The evaporation of water mainly results in cooling. The cooling tower is one of the virtual devices in the chemical industry. For example, when hot water comes from the heat exchanger that we use to cool the cooling tower. A cooling tower is a crucial component of many refrigeration systems. It also can be found in industry that require process cooling, such as power plant, chemical processing, steel mill, and many manufacturing companies. Industrial cooling tower can be larger than HVAC system and collecting heat from circulating cooling water system used in power plant, petroleum refineries, petrochemical plant, manufacturing plant for natural gas, food processing plant, and other industrial installation. What is the best material for cooling tower? Engineered plastic. Engineered plastic is designed to stand up to wear and tear. It does not rust or chip, and it can weather harsh environmental conditions. It also requires almost zero maintenance and has more life expectancy than 20 years. Advantage and disadvantage of cross-flow tower and counterflow cooling tower. The advantage of cross-flow cooling tower can be operated at higher velocity than counterflow tower, lower power consumption, constructed wider and shorter than counterflow towers, relatively easy to maintain. However, the disadvantage of cross-flow cooling tower is air travel through a shorter path than in counterflow towers, lead to lower thermal efficiency. Coldest air does not contact the hottest water, leads to lower thermal efficiency. Counterflow cooling tower advantage: highly efficient. Design allow air to flow at a relatively high velocity, preventing the backflow of humid air, more economic than natural draft towers. And disadvantage of counterflow cooling tower is fan power is required, and induced air design place the fan at the top of the tower, leads to structural and noise problem.